what is the requirement of knowing to study about circles? So a long ago, before calculators, before any machine, before even you were born, there was a city that had forgotten how to build. So their balls were cracking, right? Their wheels were wobbling, their wells were collapsing. Nothing was working at that time. The most intellectual people of those days were collected. They were doing arguments and all, but still they were not able to fix the issues. Okay, so they built for years, but in real they built nothing because they were incapable of doing it. And someday a quiet old traveler arrived the gates of the town. No one knew his name. Okay, he carried a long rope and a wooden nail. Just a rope and a nail with him, the wise man. But people were laughing at him. Like, what a old man can do rope, with a rope and a nail. He said nothing. What he did was he nailed the nail he was carrying into the ground, like right here. He tied the rope at one end, and the other end of the rope he tied on his feet. This is the old man. So another he tied on his feet. Then when the rope was extended, okay, he moved. And when he moved in such a way, people show us he draw a ring, because when he is stepping around it, he's making a ring like this. And where he walked, his footsteps, the shape it was created, it was a perfect circle. Okay, and then he said, everything you build, it was failed because of this, because you were not aware about this particular thing, the circles. Your wells were collapsing from inside, your walls were cracking from inside. Why was happening? Because you were not having the concept of circles, because you never understood this. He showed them that every point, see, that is the crux, every point lying, or every footstep, that is every point lying on the circle, the green dot that you are seeing, they are at the equal distances from the nail. All the footsteps were always at an equal distance. People find it very mysterious, very magical. Like, how can it possible? Like, he's not having anything. How does he know? How did he walk at the same distances? Okay, I'm not saying almost the same, I'm saying exactly the same. The distance, the green dashed line I'm drawing, they were exactly the same lines. Okay, people found that thing very magical, very miraculous. He also showed them, if you somehow will drop a stick like this, the stick will not intersect the circle, like will not cut the path, will just touch it at any one point. See, it is touching at any one point. So if a stick is there which only touch the circle, only touch the pathway, the circular pathway, the footsteps at only one point, the miraculous thing about it was, okay, that it always creates a 90-degree angle right here with the nail it was creating a 90-degree angle always. See, then he took another stick and dropped it here, right here, like this. The condition is it should only touch the circle at one point, at only one footstep. There also with the nail, the point of contact of the stick and the nail, it is still creating a 90-degree angle. Okay, 90-degree angle also known as perpendicular angle. So these sticks, we will tell them these sticks. For example, I'm naming these sticks like tangents. A special name I'm giving to the sticks of the wise men, tangents. So he dropped a tangent and he found that tangent is at the perpendicular angle with the nail, with the center of the circle. Two miraculous thing. People found that thing very miraculous. Okay, at that time, the old days. Third thing the wise man said, he called two people and he asked them to stand anywhere in the circle. Anywhere in the circle. For example, there is a guy A right here. There is a guy B right here. To A and B, the wise man said, I am putting a wooden log here, right here. A wooden log. Another stick, you may imagine. But this stick is not tangent. Tangents were only the stick who were touching the circle at only one point. Here it is touching at 2 points, so it's not tangent. The special name of this stick, the wise men called it chord. CHORD, chord. Remember this, a stick which touch the circle at 2 points, it is chord. Which only touch the circle at 1 point, it is tangent. Tangent is always outside the circle. Anyways, we'll talk about them later. It's not the point. We were seeing what is the third miraculous thing, the third fascinating thing. Okay, he said, I have dropped a stick right here. I'm calling the stick as chord, a special name to the stick. Okay, chord, and two persons, person A and person B. He told them, observe it, observe the log, observe the stick, observe the log, observe the chord. So whatever angle, see the eye, their eye makes. See, this is their eye. Yeah, this is their eye. If you can imagine, this is the eye of the B, right here. So whatever angle their eye makes, see how does eye make the angle? I will first see this particular end of the stick, then this particular end of the stick. What angle it is making? I'm calling the angle as, let's say, theta. Just a symbol for angle, theta. We call it theta. It is represented by a O with a dash in between. Theta. Anyways, I'm calling it theta 1. This is the angle it is creating. So when the, okay, so angle only tells us how the amount of in a way opening for his eye, like how widely it is opening his eye. So he is opening, A is opening his eye, theta angle to see this log. B is opening his eye also to a certain angle to see this particular end of the stick, and then the bottom end of the stick. B is also opening his eye. We also make an angle. I'm calling the angle as theta 2. Angle is nothing but the amount of opening, if you can imagine. Like this is a bigger angle, bigger opening. This is a narrow angle, narrow opening. This is even narrow, and this is very narrow, right? This way. So the angle, the amount of opening, theta 1 and theta 2. The wise man said, your angles are also equal, theta 1 and theta 2. You guys are sitting on the circle A and B, and you're observing a same object, a single stick, same thing, but from different places. But your eyes are still making the same angle, theta 1 and theta 2. And this third thing fascinated the crowd a lot. People were really gasped because it seemed like a magic, but it was mathematics, not magic. It was law. What law? The circle, they realized, was the most disciplined shape in all creations. See, it looks very simple, simpler than squares, rectangles, because it's a shape with no sides, no edges, no corners. Circle has no sides, circle has no corners, right? Seems very simple, but it is the, in a way, most complicated, law obeying or disciplined shape in mathematics. Okay, because it is ruled by secret laws, multiple laws that we will see, multiple theorems also. And hence the city was rebuilt. The city then was rebuilt when he got this concept for construction. And it stood for 1,000 years. And the old man then vanished, leaving behind only his rope and his nail and the round secret of the circle. For centuries, people were wondering, like, who was that guy? Well, I'll tell you, it was me. Alright. It was just a story to let you know about the concepts. So we have learned it, three things here. What circle is? Circle is a shape which substance. Okay, when you will, the distances from the center, the nail, and the footsteps, the circle itself, the shape that you see, and you see the footstep from the above, that is circle. So the distance between the center and the circle, the nail and the rope, okay, the rope itself will be of the same length across the circle. I'll draw it simply this time. See, if this is my circle now, and this is the center, the nail, and that is the rope. The dead dash line is the rope. So rope will always be of same length at any point of the circle. See, this is the fundamental property of a circle. This length is always same. Radius, r, r, r. Second thing we learned it from the tale was the story. Tangents. A stick which lies outside the circle touch the circle at only one point, and we also learned a property about it. See, it is touching right here. I'm calling the point as P point. At any P point on the circle, it is touching at only one point, P point. It makes a 90-degree angle. So tangent, the special stick by the name of tangent, it makes 90-degree angle always with the radius. And what is radius? Okay, radius is the line, the length from the center O to any point lying on the circle. Right now it is O and P. The length of O and P is radius R. So radius subtends 90-degree angle with the tangent. Third thing we learned is about chords. We get to know about chords. So chord is any line which cuts the circle at 2 points, like this. 2 points. What 2 points are these? So you can call them anything. I'm calling it A and B. A point and B point. This is chord. Okay, so the sticks are the same, tangents, chords, but different name, different properties. Tangent remains outside. Tangent is not allowed to be inside. Tangent is outside, only touch at one point. Chord is inside, always cuts the circle at 2 points. You cannot extend it. Okay, it only touches the two edges of the circle. That's it. A tangent is a line. A chord is a line segment. That is a finite line. A chord is a finite line. You cannot extend it. But a chord is extendable to infinity. That is the thing. Also, we learned it that from any 2 points, from here and here, a chord subtends equal angles from all the points of circle. For example, I'm choosing this point. From this point, a chord will subtend equal angle always. See, from here to here, whatever angle is there, this angle is theta, for example. So this angle remains theta always. See, the point of observation is P. So even for P, the angle remains theta. I can show you. See, from P point, draw 2 lines. Because at least you need 2 lines for drawing an angle. So at P, the angle is also theta. You now imagine. The angle is same. Here also and here also. So at any points, at P, I'm calling this point as S, at S point, at P point as O point, Q point, whatever points, infinite points are there on circle. The angle remains same for a single chord AB. Alright, this was the introduction of the lecture. Circle is quite fascinating. It will remain with you, okay, as you go for the engineering, architecture, it will be there. The shape looks simple, but it carries some miraculous theorems that we will see in this lecture. All right. And what we will do now, since I'm beginning the class, take out your notes and pen. Take your time. Make the heading circles. What we are going to study in circles? First of all, we will see equations. Okay, I'm just giving you a brief introduction so that you can map in your mind how lengthy is this chapter. It's not that lengthy. It's very easy. One of the easy chapter. Okay. So we will see the equations. The first thing we will see is equations. Equations of circle. See, every shape, every visual has to be defined mathematically. For mathematical defining, we assign equations. Equation are the, like, since I'm talking in a language. Equation is a mathematical language for the visuals. That's it. You have seen a shape, but you want to write the shape. You cannot write the shape. You can draw a shape, but if you want to write the shape, there is equations. Every shape has a definite equation. If you are drawing a sketch even for your face, it also has an equation. You'll find so many AI apps. You upload your photo, it will create your facial equation. Every shape has an equation. The same way, we have seen linear equation of a line. It was y equals mx plus c, if you remember. In the same way, we see quadratic equation. For quadratic, we got different equations, right? Right now, we are going to see the equation of circle. Okay, before going in the depths of the equation, I'll tell you what we will do. So equation is one thing. After equation, we will see how we will read the center and the radius if equation is given. See, equation is a source to us. We will use it. If equation is given, how we can extract information? What information? How can you draw a circle? When can you draw a circle? So circle can be drawn if you know a point to draw, the center of circle, and if you know the radius of circle. If these two information is given, the length, the radius, and the point, center, then you can draw a circle. So an equation always carry this information, radius and center. So we will learn to draw these information from the equation. Equation will be given, and we will learn how to extract the radius, how to extract the center from the equation. You will see the equation, and just by in a single sight, in seeing it, the equation, we will get to know what is the radius and what is the center of circle. Equation carries information. After we will be able to understand how to extract the information of radius and center, we will move to the messier form. See, I'll give you an equation, a standard form, but this is not the final equation form. If you remember, in the linear equation also, y equals mx plus c, it was the slope intercept form. Then there was one ax plus by plus c equals c. This is also linear, but they have different form. Okay, this was the standard form, this was normal form. In the same way, I'll give you the standard form in the first part. In third part, I'll give you a messier form, a normal form that you have to convert into the standard form that I will show you in the first part. Then in the fourth part, what we will see in this lecture, we will check. Okay, they will give you an equation will be given, a point will also be given, any point, and they will ask you if this point is lying in this circle, because equation is given. So equation is of what? Equation of circle. So you will be able to check also. For example, equation is given, it's like this for this circle, and a point is given, x comma y. So you have to check if this point is lying on the circle, outside the circle, or inside the circle. Three possibilities are there. So you will be able to check after this fourth part. Then we will learn to see where a line meets a circle. Where does a line meets a circle? Where does a line meets a circle. Meet a circle. We'll see that. Okay. What does it mean? Where does a line meet a circle? So I'll give you a stick, and you have to, or I'll give you a stick, I'll give you the equation of circle. Equation will be given, a stick will be given to you, and I'm gonna ask you, tell me if this stick is tangent or the chord. If you remember, they were the special name of the sticks. A chord was one which cut the circle at 2 points from inside. A tangent was only touching the circle at 1 point from outside. I'm gonna ask you, out of the three possibilities, just give me a minute. Okay, I'm back. Can you hear me? Okay. So we will check where does a line meet a circle. So if you remember, line means a stick, circle means a equation of circle. Line means a stick, circle means a equation of circle. So these two things will be given. A stick is what? A stick is a line. So they will give you an equation of straight line. Y equals mx plus c, if you remember. Y equals mx plus c. We will go into details of that. Don't worry about that. So a line is given. When I say y equals mx plus c, it itself means a line is given. Okay, not visually but mathematically. It's a line mathematically. They will give you an equation of circle. That means they are mathematically giving you a circle, and they are giving you a stick, giving you a circle, then asking you if this is stick a tangent or a chord. You have to tell it, or neither. It can be neither also. Like if it is lying outside anywhere, like this is my circle and this is my stick, neither a chord or nor a circle nor a tangent. It's not even touching or intersecting. It's just lying outside, far away from the circle. Three possibilities are there also in the fifth part. We'll check about it. Okay. And then later we will see tangents in detail, like in a bit detail. After this, the introduction seems a bit bigger now, but it's not. Every part will take just a few minutes. It's one of the easiest chapter, but one of the important also. So we'll talk about tangents in detail. That particular stick which lies outside the circle, outside, and touches only at single point, like this. So we'll talk about that, its properties, okay, or what questions they can ask us in the exam on this. And then we will see how can we build a circle from a scratch. A center is given, okay, and where does it pass? So for example, a center is given and any point, a center is given, central coordinate are given, center point is given, and any point, like for example P point. So P point coordinate is also given. Two coordinates will be given, and they will ask you create the equation from this. How will you create the equation? We'll talk about that also. Eighth part is they will create the complicated kinds of numericals questions from circle. They will ask you like if the angle being created is 90 degree or not. For example, the angle subtended by semicircle. See, this angle is 90 for sure, always. It's a property of, this is why I'm saying a circle has very mysterious properties. So this angle will definitely be, how do I know this? So if your diameter is your chord, that is a stick which touches a circle, the biggest stick which touches the circle at 2 points, this is your diameter, the biggest stick. Otherwise the stick will be smaller and smaller as you reach the ends, top and bottom. This is the biggest stick. So the angle subtended by the biggest stick, which is known as diameter. Diameter is twice your radius. Okay, the diameter subtends a 90-degree angle with the circle. We will learn how to check it, how they can form question on this. And the last thing in this chapter that we will see is the perpendicular from the center to the chord bisects the chord, a property of a circle. What does it mean? It means that in any circle in the universe, okay, you have given a chord. You are having a chord already. This is my chord. A stick which touches a circle from inside at 2 points. We have the chord. They are saying that you will draw a line from the center on the chord. See, you will draw perpendicular line, 90-degree making angle. This angle should be 90-degree. If this angle with the red line and blue line is 90-degree, then your blue line has already divided your red line in equal two parts. We call it bisecting. Dividing the line in equal two parts, it's bisecting. Or anywhere in any parts, it's intersecting. Bisecting means in equal two parts, it's bisecting. Okay, and the normal one is intersecting. So it will definitely, if the angle is 90 between the red line is the line drawn from center on the chord. If the angle with the red line is 90 with the red line, with the blue line, then your red line is already been divided into two parts, bisected already. Okay, this was it, the introduction. Now we are starting in detail. Equations of a circle. I already told you how will you mathematically write a circle. If I ask you draw a circle, you'll simply draw a circle like this. But for that also you require the center O. For that you also require a radius. Then if you have these two information, you can visually draw a circle with these two information. This is O and this is any point P and this is your radius R, capital R. Alright. But mathematically, how will you write a circle? So when I say write a circle means write its equation. How will you do it? Okay, let's discover the equation together. I'm saying the center. Let's assume the center coordinates. Let it be A comma B. A comma B is the central point. A comma B is the coordinates where you just take the nail, if you remember the example. Center coordinates is A comma B. And any footstep, like any point on the circle itself, is x comma y. Since x comma y is a variable, we have assumed that A comma B is a fixed value. They are not variable. It's a constant. They are numbers. A comma B are numbers, for example. We have assumed it. X comma y are variables. They are the changeable values. Okay. So see, a circle has infinite footsteps. Infinite points. The blue points I'm drawing, they can be infinite. There is no limit of drawing points because you can draw infinite point between any 2 points. Anyways, so I have taken a random value x comma y, which is this P point. Hypothetically, at this particular time, it is P point. X comma y, any point. So your P point represent any point lying on the circle. When I say lying on the circle, I mean the black line. This is a circle, nothing else. Not the inside or the outside, but the black line only. The boundary. This is circle. So any point P lying on the circle with the coordinate x comma y and the center is A comma P. If these two things are there, do you remember the distance formula from coordinate geometry? Distance formula was D. Distance equals, even if you don't remember, this was the formula. If any 2 points are given, the ending point and the initial point of a line is R. OQ is the line. Okay, OP is the line. OP, for the OP line from here to here, what is the length of this line? If the coordinates of O is given, if the coordinates of P is given. So distance D. In coordinate geometry, we have know the formula. Formula is under root or square root, we call it. First coordinate minus, okay, final coordinate minus initial coordinate. So final x value minus initial x value. Square plus final y value minus initial y value. Y is the second value, x is the first value. So final means, because P lies on the right side. So it is final, and this lies O lies on the left side, so it is initial. That means I have just done the final first value x minus initial first value a. So x minus a whole square plus final second value in the coordinates first and second, first comma second, minus initial second value, which is b. So we got the formula. This is the formula, distance formula. And what is the distance? Do we know the distance already? Yes, it is the radius. Distance between O and P is radius r. So r equals square root x minus a whole square plus y minus b whole square. And we are very close to write up equation. We are very close to discover a equation of circle. See, I'm gonna move this square root on other side. Then it becomes a square of r. So r square equals, square root is removed because it has made the r square. So x minus a whole square plus y minus b whole square. This is the equation of circle. I'm gonna interchange the sides now. This will be the final equation this time. X minus a whole square plus y minus b whole square equals r square. This is the equation of circle. Okay, just in the same way you have remembered the equation of straight line, y equals mx plus c. Equation of quadratic was ax square plus bx plus c equals y. In the same way you have to remember the equation of circle also. Remember this. Okay, log this thing in your mind. X minus a square plus y minus b square plus r square. And you already know the inference, the meaning of each letter here. The meaning of each thing I have written here. What is r? R is the radius of the circle. Remember this. What is a and b? So check a and b. A and b was the center of the circle. So a comma b here that you are seeing, a and b in the formula, they are the center. So, and x comma y is any point. Okay, there are infinite points, so this value is not known. Otherwise everything in the equation is known. So don't we know everything? We know the center a comma b, we know the radius. So once you have given an equation, you already can grab the information of center and the radius from the circle. I'll show you an example. If I'm having an equation like this, x minus 1 square plus y minus 2 square equals 4 square. So if you already know circle equation, you know what are these. You want to get the radius. What is radius? Radius square. See, 4 square, you can compare them. That means the radius of this circle, this is circle only. It is the equation of circle. We can see that. We can compare these two. They look similar. So 4 is there, r square is, that means radius itself is 4. 4 units. We got the value of radius by comparing them. Do we know the center? Center is a comma b. A was here, b was there. So 1 is there, 2 is there. That means center is also 1 comma 2. 1 comma 2. Okay, this is how we can grab the information. Second part I was talking about. One more example. Always remember what values to compare. See, x remains x minus a. In the place of minus a, you are having minus 1. Minus minus cancel out. A equals 1. You got the value of a by comparing it. Then by and by, they are same. Minus b and minus 2. So they look similar, and b equals 2. R square and 4 square. That means r equals 4. So you got a and b, a comma b. That means a comma b is 1 comma 2. R value is 4. This is how we can grab information. 1 comma 2 is the center and r is the radius. 4 is the radius. Okay. I'm gonna give you one more equation, and then we'll try to grab the radius and center from the equation. And this time it may get us wrong. Okay, let's check it out. We are having x minus 2 whole square plus y plus 3 whole square equals 5 square. How will you do it? Find the radius and find the center from the equation. So check it out. In the place of x, we are having x. In the place of minus a, you are having minus 2. That means a value is 2. Y is y. Now this is the game. Minus b. In the place of minus b, you are having plus 3. Not minus 3. Minus 3, if it was there, then they were simply compared. B equals 3. But no, this time it is minus b in the standard equation, and this time it is plus 3 in this equation. That means you have to compare minus b equals 3. That means b equals minus 3. It's not that simple. B is not 3. B is minus 3. I hope you get it. I have compared minus b with plus 3. Earlier it was minus a and minus 2. So a equals 2 simply because minus minus there. But here it is minus and plus. That means 3 has to be negative because minus b is there. And b value is then not 3 but minus 3. Otherwise you will write the wrong answer. And hence your center coordinates becomes a comma b, which is 2 comma minus 3. 2 comma not 3 but minus 3. 2 comma minus 3 is your center. What about the radius? So r square and 5 square. That means radius is 5 units this time. Okay, this was it. Okay, let's complicate it. Let's go one step further. What if a radius is not given? For example, they may not give you 5 square. They may give you 25. And you know what is 25? 25 is 5 square again. So the radius remains 5. You have to convert the square. If a square was not given directly, you have to compare it by yourself. You have to create a square by yourself. Now 25 is a perfect square. What if you don't have a perfect square? You have a 7. Not 7 square, only 7. You have to write 7 in square root 7 square. You have to write in the square form. Then your radius becomes root 7. This becomes your radius. Okay. Okay, I hope I am audible. It was a power cut for a moment. So I lost my Wi-Fi, but it works for now. It's back. So we were comparing, we were extracting the information from the circle's equation. It's not a very tricky part. It's very easy. So I'm gonna give you a different thing this time, and you have to extract the information from it. X plus 1 whole square plus y minus 3 whole square equal 10. This is given, and now it definitely does not look like a circles equation. How do you know it's circles equation? So you already know, you have to learn the circles equation in your mind. See, a, you have to remember x minus a whole square plus y minus b whole square equals r square. You have to remember this equation. Then they look similar. One bracket is square plus second bracket is square plus some other value equal some other value. Okay, this is how we can know that it looks like a circles equation. Then what? Okay, let's compare it. So in the place of minus a, when you compare it, you are having plus 1. That means a value is minus 1. This minus will move to the other side. You got the a value. Then in the place of minus b, you are having minus 3. Exactly. That means b equals 3 this time, simply. And what is a comma b? If you remember, a comma b was a center. So center equals minus 1 comma 3, isn't it? Center equals a comma b equals minus 1 comma 3. So from the given equation, you have already got the center, extracted the center. What about the radius? So in the standard form, it is r square, but there is no square here. Let's create a square. It becomes square root 10 square. It remains same. We can do it. Every number is a square of its square root. So 10 is also a square of its square root. We have done it. So r square, and here square root 10 square. That means r equals square root 10. We got the radius also. Always write the radius with units, with the spell units, units, units. All right. Let's see one more equation. Okay. This time we are having x plus 7 square, x plus 7 square, and then plus y plus 2 square equals 100. Then what? Let's compare it with the standard equation. By this time you shall be remembering this. Okay, it's non-negotiable. You should be remembering the standard equation. Now we just have to compare them with the standard equation. And if you remember the standard equation, which says, I'm going to write it again for your case, x minus a whole square plus y minus b whole square equals r square. We have to compare these two. Okay, this will not be given. The standard one, we have to remember it. And the information also, I'm going to write it. A comma b is your center always, is your center. R is your radius always. So in the equation, it's radius square. Let's do it. When you compare it, your a value will be minus 7. Your v value will be minus 2. So your center coordinates are minus 7 comma minus 2. This is your center. What about your radius? So radius square, which is 100. So radius square is 100. That means your radius is 10. So we got the radius also 10 units. We got the center also. This is how we are going to do the questions. All right. So if any equation is given, we are now good in a position to know the center and know the radius. I'm going to write one more and I'm going to just, I'll be expecting it that we shall be able to see it and answer it. What is the center and what is the radius? X minus 7 whole square plus y plus 8 whole square equals 144. What is the center and what is the radius? So I already know by enough practice that center equals minus center equals 7 comma minus 8. That's it. Radius equals 12 units because 44 can be written as 12 square, so we have to grab only 12 units. Okay, so now after this lecture we should be able to know the center and the radius from any circle equation that we will see. Okay, now the tricky part is, this is very clear. Now if a equation like this, a bracket square plus another bracket square equals a number, if such a equation is given, we can know the center and the radius very easily. What if the equation is not that simple? Like how simple it is? One bracket is square plus another bracket is square equals some number. What if equation is not like this? Not a bracket is square, something else. What if the equation is of this form? X square plus y square minus 6y minus 4y minus 12 equals 0. What is the equation of this format? It definitely does not look like this, because we are very familiar. See, we are only adapted to know the center and radius from such kind of equations. One bracket is square plus second bracket is square plus equals some number. Then only we are able to find the center and radius. What if this is also a circle equation? This is also a circle equation. Okay, they have given us. How will you know the center and radius? This is the question. So for knowing the radius and center, the process remains same, but from this equation you have to convert this equation, the given equation, in the standard form. What was the standard form? It was x minus a whole square plus y minus b whole square equals r square. We have to make it look like the standard form, like this. And how will you make it look like this? So step number 1. So from the messy form, the equation is given like this one. What will you do? The first thing, is group the x values together like this. X values together. The first step is group like terms together. Like means x together, y together, number together. So like terms together, collect them up. This is the first step. I'll show you. So x square plus another x value is minus 6x. Okay, it is collected. Now it is collected. Now plus y square minus 4y. Okay, y value is also collected. What now? Okay, let's move this minus 12 to the other side. 0 is a number, 12 is a number. Let's move this number to the other side, number with number. So it becomes 12. When negative number moves to the side, it becomes positive, plus 12. Now it looks like something, something similar. One bracket is there, not the square yet. Another bracket is there, not the square yet. Equal some number that we wanted. Now what? Let's make this bracket into a square. Let's make and this bracket also, the by bracket also, and into a square. And now, do we know this? How to convert a normal expression into a square? It seems like we do. We have seen in quadratic the completing square method. We have to complete the square. See, the square is not completed. We don't see a whole square here. We do see a square over x, but we don't see a whole square. You have to make it wholly, completely. Let's complete the square. Let's make the square over the whole bracket. Let's create the square over the whole bracket. How will you do it? By using the completing square method. if you remember. So we will grab this bracket first. Okay, we have to do it individually. X square minus 6x. Apply the completing square method. Okay, I'm not going into the depths of it. When you apply the completing square method, it will look like this: x minus 3 whole square minus 9. It is the completing square method. In the same way, apply the completing square method on the by bracket also. On the by bracket is y square minus 4y. When you will apply the completing square method to the by thing, it will become into y plus 2 whole square minus 4. This is how we make the completing square. Okay. For completing square, I'm assuming you already know how we did this, how we converted from this to this. Okay. And since we have used the completing square method, what method? Completing square method. Here also we have used the completing square method. Once you are done, then let's switch the value. The value of x square minus 6x is this. So in the place of this x square minus 6x, let's put this value. In the place of y square minus 4y, let's put this value. This one here. And when you will do it, we'll see a new visual. It will become, so in the place of x square minus 6x, I'm going to write x minus 3 whole square minus 9 plus y plus, because it was a plus sign. See, there's a plus sign here, plus y values. So I'm gonna substitute this into y plus 2 whole square minus 4, and it was equal to something. It was equal to 12. See, equal to 12. And again, let's collect the like terms together. So x value is already together in the brackets, it's closed. Y is also enclosed in the brackets. Numbers are not. Let's write the numbers on other side, all the numbers. So x minus 3 square as it is, y plus 2 square as it is. Numbers on the other side. So minus 9 minus 4, that is minus 13. Minus 13 when moved to other side becomes plus 13. 12 plus 13. 12 plus 13 is 25. So one bracket is square plus second bracket is square equals 25. Now, does it look like the standard form of circle? Yes, it does. The standard form of circle is x minus a whole square. I have written this standard form, I think, more than 10 times now, so you should be able to remember it. Okay, it's non-negotiable. X minus a whole square plus y minus b whole square equals r square. We got the standard form now, and we have converted the messy form in the standard form. See, these two look like same. One bracket is square and plus another bracket is square equals some number. We got this, and we are very familiar to extract information. So from this equation, can you tell about the center and the radius? So radius is, so for radius we want to convert this 5 into 5 square. So this 5 becomes a radius. 5 is the radius. What about the center? Center is a comma b. So minus 3. Okay, so center becomes 3 comma minus 2. We have practiced enough to find it out, because you compare these two, x minus a whole square plus y minus b whole square. So a and a, see, minus a and minus 3, so a equals 3. Minus b and plus 2, different sign. Whenever there is a different sign, minus b and plus 2, so it will be minus 2 this time. When they are same, minus and minus, so it's plus. Minus and plus, and wherever there is a plus sign here, it should mean minus, minus 2. We got the center, we got the radius. When the equation doesn't even look like the standard form. See, it was quite hard to imagine that we got the radius and the center from forward equation, from not the standard equation, from this messy equation. This one given to us. What were the steps? Firstly, you have to group the values together, x together, y together. And when you do it, numbers to the other side. When you do it, you have to complete the squares of each bracket. When you do it, again, move the numbers to the side. This minus and minus 4, make it to the other side. Then you will see the standard equation. one bracket is square, second bracket is square equals some number, and you are already familiar how to extract the center in the radius. And what we will do, okay, right now I'm keeping it till here only. When we will meet in the next class, okay, when we will meet in the next class, we will see equation is done. We already know what the standard equation, we know about it, it is done. We already know how to extract the radius and center. What we do know is, in the last we have seen the messier form, how to convert the messy form of the equation into the standard form. We have seen that, and then extracting the radius and center, you know about it. Now when we will meet, we'll do this thing, checking if the point lies inside the circle, outside the circle, or on the circle. We'll check about it. Then we'll see if the line cut the circle at 2 points like this, or at only 1 point, or doesn't even cut anywhere, it's outside, far from the circle. Then we'll check for the tangents. We'll see centers and other properties in the last. So it's quite, you may find it quite difficult, but I need you to make your notes. If you are making notes and writing everything I'm saying exactly same, then you will never forget anything from it. All right.